So now we're going to do some example problems from section 2.1. First thing we're going to do is identify the vertex of a quadratic. So describe the graph of the function and identify the vertex. So that is a quadratic. Now if you look carefully, if you were to say write this out in standard form, this would be negative 1/4 x squared minus 6. Please note that there is no value for b. Now you can either recognize that this thing has a vertex of 0, -6 because it hasn't been shifted left or right. Or if you want, you could do the x equals opposite b over 2a. It just turns out that b is 0. b equals 0, right? So you're going to take -0 over 2 times -1/4, which is, you guessed it, 0. So that means that the vertex is 0, right? And then you plug 0 in, and if you plug 0 into this function, right? So if you take f of 0, you get -6 because you put 0 in here and all that's left is the -6. So that is the vertex. Now, is the vertex a min or a max? To this, we look at the lead coefficient, which is negative, which means that this quadratic opens down, which means that this is a relative max at 0, -6. Okay? This one's a little bit more straightforward, believe it or not, because you can just go straight to this. There actually is a value of b. Remember, a is 0? No, it's 1. b is 3, and c is 1/4, right? So, opposite b, -3 over 2 times 1 is -3/2. Now it's okay to write this as -1.5, which means the vertex is at 1.5. Now to get the rest of this out of the way, because now I'm actually have to do math. Okay, I'm doing math. I hate to say it, but calculations, yes, arithmetic, plus and minus and all that good stuff. Then what I'm going to do is identify if this is max or min. So this has a positive value, so this is going to be a relative min. That's what the vertex is, right? At 1.5, -1.5. Nearly lost a negative, see that, right? So when I plug -1.5 in, what do I get? So I take -1.5, I square it, which is the same as 1.5 squared, FYI, plus 3 times -1.5, then plus a quarter, so plus 0.25 is -2. Well, that's actually a nice round number, isn't it? Okay. And that, friends, is how you find the vertex. So, identifying x-intercepts. X-intercepts, now the book goes a long way towards saying that x-intercepts are the form of number, comma, 0, right? There's more than one, so it's a coordinate is all, right? So identify in this sense, describe the graph of the quadratic. So this is a quadratic that opens down, correct? How do we know that? Because of the negative sign. Identify the vertex and x-intercepts. Use graphing utility to verify your results. So f of x equals opposite. I'm going to try factoring. So looking at this, two numbers that multiply to get 4, like 1 and 4, could have a difference of 3. So I think this is going to be factorable. So I'm going to look for numbers, and I just did, right? 1 and 4. Having some number sense helps. But if I add or subtract these, or if I subtract them specifically, I get 3. This multiplies to get a negative, which means one of these has to be positive, one has to be negative. That's how the world works. If I went up with a positive 3, that means that the 4 would have to be positive, and this would have to be negative. Don't sit there and rest on your laurels at this point, because it turns out the roots are at 1 and -4, which means if someone wants to get fussy with you, the x-intercepts are at 1, 0 and -4, 0. I'm fine if you say that the x-intercepts are at 1 and -4, same thing. Now, interesting / curious thing. You could find the vertex, and we know that this thing has a relative max, right? Because it opens down, by using our opposite b over 2a thing, or, now, I'm just going to ignore this negative for this, okay? And that's okay. So it's going to be x equals opposite b, -3 over 2 times a, aka -1.5. Now, that means that this is -1.5. Remember, the vertex, these things are symmetric, right? So it turns out the roots are also evenly distributed about this. So that means, or that is, they have the same distance, meaning the vertex is halfway between them. So if I take the average of those two values, that is, add them up and divide by 2, I get negative 1.5. That is not a coincidence, but it only works with quadratics. So now I have to do my good old plug numbers in thing, meaning I'm going to take negative 1.5 and square it, and then I'm going to then do that, and then I'm going to do that, and then I'm going to make sure that I multiply through by the negative 1. Don't forget the negative 1, which means this is a relative max at negative 1.5, 6.25. In other words, the same process we used for the last question. All right, writing the equation of the problem in standard form. So vertex point. So standard form is this whole rigmarole. That's an H, not a B. H plus K. So the vertex, negative 4, negative 1. So this tells us negative 4 is the x value, x with x. So that becomes plus 4. And negative 1 means, don't forget the squared. That's kind of embarrassing if you do, minus 1. Why do they give you the point? We know where the vertex is, right? Let's just assume it opens up. It may or may not. We're not sure yet. So we know where the vertex is, right? It's here at negative 4, negative 1. You'd need another point to figure out, because there's a bunch of quadratics that could open up or open down, another point, which is what this is, to figure it out. So what you do is you take and plug in x for x and y for y. So 4 goes in for the y, remember x comma y, and then a. A is the stretch that either causes it to be positive or negative, right? The reflection, right? To get it open up or open down, as well as conform, that is stretched to include that point. So that would then be negative 2 plus 4 squared minus 1. Order of operations, folks. The squared is kind of important. Negative 2 plus 4 is 2 squared is 4. So this is 4a minus 1 equals 4. Add 1. Divide by 4. A is equal to 5/4. If that bugs you, write 1.1 or write 1.25. But this works too. And thou art done with what they call standard form. Remember, I prefer vertex, but whatever, right? Okay, the path of the diver is approximated by, hey, that's kind of looking sucky, doesn't it? Where y is the height in feet and x is the horizontal distance in feet from the end of the diving board. So you want to make sure that's not 0, because otherwise you go up and down right into the diving board. So what is the maximum height of the diver? So if you're looking at this is a quadratic, right? Which means the maximum height is right here. Whatever you do, don't draw in my book, or actually you don't have a book to draw in, so don't just say there, here it is, right? That's a little bit, But could you figure out the vertex? Oh, wait, yeah, you can. So it's negative 24/9, there's a nice round number, over 2 times negative 4/9. Now on a positive note, negative over negative is going to be positive, right? So we have 24/9 divided by 8/9. Now these are horrible, nasty decimals. Okay, this is actually 0.8 repeating. This is different than that. But remember, this is, if you can remember your dividing fractions stuff, then it turns out that you get a nice round number, because the 9s will cancel. 24 divided by 8 is 3, which means x is 3, which means you could then plug in y to find the maximum height. Remember, 3 is the horizontal distance traveled, which is 3 feet. You want to know the maximum height, right? So what you do is you figure out f of 3. We call that function f just because we just did. So that's negative 4/9 over 3 squared times 3 squared, sorry, plus 24/9 times 3 plus 12. That's 9. The 9s will cancel. I get negative 4. 24 over 9 times 3. Okay, so that's the same as saying 24/3 plus 12. I gotcha. This is negative 12/3. This is 24/3. And this is 36/3. How? Common denominators multiplied by 3, right? Negative 12 plus 24 is 12. 12 plus 36 is 48 over 3. And you could have used a calculator, but it turns out that the max height, it's not the height of max, it's the maximum height, is 16 feet above the water. And that's how you do that. And that concludes our examples for section 2.1.